Hi, so I'm doing try now 39. There are four questions. I think this is on page 508 in your textbook, page 508. So it deals with my series on parametric equations, differentiating parametric equations, okay, or parametric differentiation. All right. Let's start off going to the first question. It says the diagram here shows the curve with parametric equations. X is equal to 4 times the sine of theta, and then you have y equals 1 plus 3 cosine of all of theta plus pi over 6, and theta being an angle between 0 and 2 pi radians. Right, so we are going to show that dy dx can be written in that form, where the exact value of k is to be determined. So at the end of the day, we will have to say that k is equal to something. That is what we also need to do. Okay, right. That's part A. Part B says find the equation of the normal to the curve at a point where the curve crosses the positive x or the positive y axis. Now, if a curve crosses the positive y axis, um, the positive y-axis, that is when x is equal to 0. Okay, when x is equal to 0, and dy dx, if you are dealing with that, it will mean that it's either a scenario where the denominator of the derivative is going to be equated to 0, and then you take it from there. And of course, they want you to write it in the form y equals mx plus c. All right, so let's go directly to it. Take it in parts. We'll start with part A. Right, so we are going to do dy dx. So I'm going to do them next to each other. The first one obviously being y equals to 4, or no, x rather, equals to 4 sine theta. This is going to be dx d theta is equal to 4. The sine, the derivative of sine is cos theta. Therefore, d theta dx is going to be 1 all over 4 cos theta. Okay. Then obviously I'm now going to look at y equals 1 plus 3 cos of theta plus pi over 6. Okay. See, yeah, that is that one there. All right, so let's find dy d theta. So dy d theta, and maybe before I start doing the derivative of that, maybe I should maybe clean up a bit. It's quite um, a handy thing to do, because in here you have got this scenario with this compound angle here. So I'm going to do that also. Okay, so before I start doing anything there, so I've got a y equals 1 plus 3, and then I have the cos of theta plus pi upon 6, so that compound angle there, y equals to 1 plus 3. Then this is cos theta, cos pi over 6, minus, so that's plus, obviously it's going to become minus sine theta sine pi over 6. Right, this is going to be y, which is that cos theta. I'm going to, because this is a value that does exist, which you can obviously use your calculator, minus sine theta, value that exists. But now remember our work from special triangles. If I go back to our work from special triangles, so let me just close off that little bit there. Then the work from special triangles, you should know that if you had, a triangle like so, Okay, so let's say that's pi upon 2 or 90 degrees. This is pi over 3. This is obviously 60 degrees. And this is pi over 6. This is obviously the same as 30 degrees. Then this is 1, and this is going to be 2, and this is going to be the square root of 3. Now, I'm going to find a number of things. So I'm going to find the cosine of pi over 6 and also the sine of pi over 6. That's what I'm going to input here. So the cosine of pi over 6, cosine is adjacent of our hypotenuse, which is that over 2, and also the sine of pi over 6, the sine of pi over 6 is the sine of pi over 6 is a half is 1 over 2. So you can naturally use your calculator if that is a little bit too tricky for you. You know, you can make sure your calculator is in radian mode, I believe. Okay, mine is. So your cosine of pi upon 6, of course, you're going to get root 3 over 2 as I indicated. And then the sine of pi over 6, which is just going to be a half. Okay, right. So these values are going to be substituted in there because, again, as I said, where we can clean this up. All right. So this I'm going to continue with. Let me just grab it so that I can continue on the next page. Take a snapshot of that. So this is, well, I don't think it will come out nicely. Let's take another one. Good. All right. So I'm gonna just continue with it on this page. So remember, I'm still busy with my y equals to, so I can actually go ahead and clean it up. I haven't yet differentiated. So this is y equals to 1 plus, I've got my 3, then I've got cos theta. This can actually be multiplied out. I can actually say this is 3 and this is times root 3 over 2 cos theta minus a half of sine theta, and I can actually distribute that over if I have to. This is going to be y equals to 1 plus 3 root 3 over 2 cos theta, numerator times numerator, and then 3 times negative, a half is negative 3 halves of sine theta. I think I'm now ready to find the derivative of that. So dy d theta now. So dy d theta, okay, dy d theta, which derivative of that is 0. This is the same as 3 root 3 over 2, and the derivative of cosine is nothing but sine theta minus 3 over 2. The derivative of sine theta is, let's come back here. The derivative of cos theta is minus sine theta, and the derivative of sine theta is cos theta. Okay, it's very important that we make sure that we don't make those type of mistakes there. So if I just have to clean up a bit, this negative, I'm just going to carry it in front. That's negative 3 root 3 over 2 of sine theta minus 3 over 2 of cos theta. Now, remember, ultimately, the name of the game here is to use the chain rule. The chain rule say dy dx. The chain rule say dy dx is equal to dy d theta times d theta dx. Okay, so we're going to take all of this, negative 3 root 3 over 2, then minus 3 over 2. I left out the ratios. Negative 3 root 3 over 2 sine theta minus 3/2 of cos theta. We're going to multiply all of this by d theta dx. So let's just quickly go back all the way to go find it. All right, it is 1 over cos theta, 1 over 4 cos theta. So we're going to multiply all of this by 1 over cos theta. Okay, times 1 over 4 cos theta by 1 over 4 cos theta. Now, it's imperative to know that here you can actually take out a common factor, and the common factor of negative 3/2 here. Then this is going to leave me with root 3, okay, sine theta minus, okay, it's just going to be minus, just make sure of that. Now I took out a minus, so it's going to be positive cos theta if you do that. Okay, so this is obviously going to be multiplied by 1 over 4 cos theta. Right. What else is there for me to do? Now, obviously, it's going to be numerator times numerator and denominator times denominator. So at the end of the day, these numbers, the negative 3/2 and the 4, 1 over 4, I can actually grab them out, okay, by saying, well, I'm going to have negative 3 over 8 if I take it out, okay? And then ultimately, I'm going to have the numerator of that, I'm going to have root 3 sine theta, okay? I'm going to put everything over cos theta, okay? Plus cos theta, all of that over cos theta. Right. Now, remember, ultimately, our goal is to write it in this form. So let me just grab that form so we can know exactly what is it that we are doing. And just save also. This is one of these. Okay, let's just take a snapshot. So we want to write it in this form. Okay, ultimately determining the value of k. All right. So let's just go down. Let's go down. I'm going to paste it over here so you can know what is it that we are looking for. So at the end of the day, we are going to put everything over cos theta because somewhere things might happen. Okay, so I'm going to have negative 3 over 8, and then I have the cube root of sine theta over cos theta plus cos theta over cos theta. Okay, now if you go inside over here, you have negative 3 over 8, then you have the cube root, not the cube root, but the square root, the square root of 3, root 3. Sine over cos is tan theta, and this is the same thing divided by the same thing is equal to 1. Okay, we are nearly there. We can just rearrange so that they can be in that form, where I have negative 3 over 8, and in bracket I have 1, plus the cube root, the root 3 of tan theta, and by comparison, k is equal to this whole value minus 3 over 8. So I can therefore conclude, therefore k is minus 3 over 8. Okay, it's quite a handful, but that is the solution to that one. Good. Now, there is a B part to this question, so I think I have most probably not enough space, so I'm just going to enter a few pages, because sometimes, you know, you think that you are not going to use a lot, and you realize, oh, wait a minute, you're actually using quite a lot. So let's just go get question. Let's go get question B. part B says find the equation. Okay, it's going to go all the way back down here. You can paste it here. All right, it says find the equation of the normal to the curve, okay, where the curve crosses the positive y-axis. And this, let me just explain a little bit more what this scenario means. So if you look at our derivative function, which is what we have over here, it crosses the y-axis at the point where x will be equal to 0. Crosses the y-axis with x equal to 0. So if we were to find our original values, remember our x equation was x is equal to 4 sine theta, and we say it crosses the positive y-axis, and this happens when x is equal to 0. So that will be 0 is equal to 4 sine theta. Where does that equals to 0? So of course this is going to be sine theta is equal to 0 because 4 going to 0 time. Let me just bring back something from a blast from the past. If you have the sine curve which oscillates something like this, and this is 2 pi, and that is pi, that's -1, and that's 1. Okay, that's the y and that's the x. Now what we are looking for, because they give us that the domain is between, so I have to go back quickly, the domain, just hang on with me, they say the domain is, yes, from 0 to 2 pi. Good. So having a look at that graph, that diagram that I have made, the values, the x equals to 0 at the following 3 points. It's going to be at the points here, it's at this point, and it's going to be that point. Okay, so therefore theta equals to 0, theta equals to pi, and theta equals to 2 pi. Okay, so we are looking for the y values now. So we're going to look for the y values. So remember, to find the y values, so first of all, when theta is equal to 0, so here's one of the things that you should remember, that you're going to get an identical answer if you were to use any one of them. So I'm going to just rewrite down what our equation was in terms of y. Of course, you can find it right there from part A. Y equals to, let's just go and grab our equation. Okay, it's all this horrible long equation over here. Y equals to that. Okay, so that is our y. So we need that because we want the corresponding point for y. So let me just bring it back in here. All right, so when theta is equal to 0, so when theta is equal to 0, then y will be 1 plus 3 cos of theta, but now theta is what? Theta is 0, and 0 plus pi over 6. Now you can go ahead and use your calculator, and then you will get the answer of 3 times root 3 over 2. This is going to be the value of y. Okay, let's see what do we get when theta equals to 2 pi. Let's see, when theta equals to 2 pi, I'm going to get to that. Okay, then y equals to 1 plus 3 cosine of, now theta is 2 pi plus pi upon 6. when you work this out, you're going to get exactly the same answer. So because it repeats over there, you're going to get the same answer. That is what you're going to get for the value of y. So y is going to be the same as 0 because that whole function repeats itself there. Okay, right. So let's then look at the other value when theta is equal to pi. When theta is equal to pi, what will be the corresponding value for y? Okay, so then y will be 1 plus 3 times the cosine of pi plus pi over 6. Of course, I've done it already, but you can go ahead and you can calculate it on the calculator. You're going to get that value, which is about negative 1.5980 radians. And what this is, the reason why I wrote it, because it's very difficult for you to see, is that this is a negative y value. And our question right from the beginning says, they say where the point where the curve crosses the positive y axis. So this is a negative y axis, so we are not going to consider. Okay, we're not going to consider because this is a negative a negative um, okay, negative. We just write it out, a negative where we go, this is a negative y direction. It's negative y direction. Okay, so the point that we are going to consider, 4x and 4y, will be will be when you have 0, comma, because the x value is 0, remember, and then the corresponding y point will be 2 plus 3 root 3 over 2. Right, now we have our point. What do we need to calculate? We need to calculate the gradient. So we need to calculate the gradient where theta is equal to 0. So dy dx, dy dx when theta is equal to 0 becomes negative 3 over 8. And then remember, we had 1 plus root 3 times the tangent of 0. And of course, now if you have all of this on your calculator, you can check. So when you check on your calculator, I'm very interested in what is going to happen inside the bracket. So you have got negative 3 over 8. You're going to multiply that by 1 plus root 3 times the tangent of 0. Now the tangent of 0. Okay, so that whole stuff inside is just going to be negative 1. Is it going to be 1? Let's see the whole answer. Okay, you get that whole answer there. So this is going to be nothing but negative 3 over 8. So negative 3 over 8. Now, what is it that we are looking for? We have the gradient. So again, let's include or append a page, because we are continuing. So what do we know? We know the gradient is equal to that value, okay? But the equation of the normal, is y minus y sub 1 equals to negative 1 over m, and then you have x minus x sub 1. Good. So our normal, the gradient of the normal, will be the inverse reciprocal of that, which is going to be, let's say, the gradient of normal is going to be nothing but 8 over 3. And we have a point 0, comma, that whole point there, which was 2 plus root 3 root 3 over 2, if you could remember. And this is going to be the x 0.1, and this is going to be y 0.1. So it's just a matter of plugging in, and then we have y minus 2 plus 3 root 3 over 2 equals to our gradient now 8 upon 3, then x minus our x value, which was 0. Okay, technically that is the answer. You can continue to clean it up, but because the question said you must leave your answer in the form y equals mx plus c, if I'm not mistaken. So let's just going to see y equals mx plus c. Yeah, it says leave your answer in the form y equals mx plus c. So we are not done with this question. So let's just go ahead and clean it up. Okay. So of course, this is y minus 2 plus 3 root 3 over 2. Well, that is going to be equal to, now here's the beauty of it. There's so many ways you can do all of that. You can say, okay, this is 8 over 3x. And I'm going to bring that whole term there. That's going to be y equals 8 over 3x. Then we're going to add all of this 2 plus root 3 upon 2. Now, the reason why I'm not giving rounded answers here is because they said you were supposed to give answer in the form y equals mx plus c, where m and c are exact. And this is very important that you don't make that mistake, where m and c are exact. The word exact there is important to you. So do not go and give these answers as decimal equivalents and so on. In fact, in this particular one, you're going to have a irrational business going on here, because the square root of 3 is irrational. So this is the correct answer as it is.